Welcome to EPG Pathshala for Linguistics. I am Vidya-mitra Sharma, a faculty at IIIT Hyderabad. I head the Language Technologies Research Center. Today I will cover with you the area of computational linguistics, the introductory module. Today I will cover with you the Introduction to Computational Linguistics module of Computational Linguistics course. Introduction to Computational Linguistics module covers an overview of the field of computational linguistics. Computational linguistics itself is an area which brings together computer science and linguistics. As the name itself denotes, it's a transdisciplinary field. In computational linguistics, we try to process natural language or the languages that you and I speak by computers. That means we develop computational models for understanding the natural language the way we understand, and try to develop applications and technologies which can make it possible for human being to interact with another human being via computers, such as machine translation application. Similarly, we can also interact with the computers directly, where we can talk to a car or a computer or ask for reservation in natural language through a dialogue system. For finding technological solutions related to natural language problems, what we do in computational linguistics is we do linguistic analysis with computational techniques. We do develop computational methods for understanding natural languages, and therefore we aim that the computers can understand the natural language the way we do. History of CL. Computational linguistics as a field of study started sometimes in 1950s. Focus in the beginning was on parsing, that means finding structures, and it all started as an attempt to develop machine translation systems. The field developed along with linguistic theories. That means that there was a lot of activity happening in the field of linguistics, where theories were being formed, and Chomsky had already arrived on the scene. And in parallel, this area of machine translation with the focus application was also evolving, where people wanted to apply linguistic knowledge to computational methods and develop applications which were of social and immediate use. So the major earlier works in the field were implementing linguistic analysis, because if we want the machines to process the human language, then it is extremely important to understand how the decoding or encoding happens in the human language. Developing language descriptions as formalisms that could be implemented computationally was the other activity that went on. And initially came the rule-based machine translation systems, where dictionaries and rules were provided to the system to process natural language, producing machine translation systems. Subsequent to rule-based systems came the statistical systems, where primarily probability-based methods were applied to develop algorithms which could process the text and provide translation. The types of analysis that followed during this period and subsequently were to develop linguistically meaningful way analysis of language. So develop methods which could linguistically analyze natural language. Object of analysis was a natural language utterance, a spoken word in which speech analysis, that is analyzing speech both phonetically and phonologically so that the system could synthesize spoken form into written text. And also in the reverse direction, where the system could read a text and speak aloud what is written. Written text analysis was also part of this, where structures in a sentence or a word label were analyzed. Speech as an area of study involved speech-to-text systems and speech synthesis, text-to-speech systems. Sub-research areas of this field are speaker recognition. That means if somebody speaks, 3 people speaks, the system should be able to identify the person from their voice. Biometrics has a lot of application. Again, speaker identification is one of the key area of this research. Speech enhancement in multi-user environments, where many people are speaking. Then how does one present the speech? Textual analysis. Object of interest is textual data and written language. Encoded in orthographic form, this text is analyzed at different linguistic levels. The levels begin with the lexical level, where a word is analyzed. Morphological analysis of a word or the structure of a word is understood. Sentence structure, that is syntactic analysis, is the next level of analysis. Semantics, that is bringing the meaning to the form, is the 4th level of analysis. And then one also goes all the way to discourse analysis and pragmatic usage. Now when one does this analysis, what one needs to architecturally design is whether one should go for a pipeline architecture, which means all these levels are analyzed one by one, and the output of one level becomes the input of the next level. For example, if you take a word, then it is first given as a form. Morph analyzer takes the form and gives in output its features, root and gender number person features. Similarly, all the words that are part of a sentence go to the syntactic analysis level, where the words now are looked at along with their features and their relation is established. That then goes to the sentence level analysis, discourse level analysis, where 2 sentences are looked in a context and how these 2 sentences are related to each other is analyzed. Now, in a pipeline architecture, the error of first level, in case some error is there in the output, will go to the next level, and the input to the next level will already be erroneous. So the chances of the errors propagating and cascading, creating a cascading effect are high. Therefore, the other approach which is being explored these days is joint modeling. An important aspect of developing any computational techniques or methods for doing language analysis is the language data. And this language data, we call it resources, has to be developed using appropriate linguistic analysis. Now, one can ask a question, why develop resources? This helps in information prediction. It also helps in creating grammars automatically. So if a large-scale corpus with appropriate linguistic annotation is available, one can extract grammar for that language. It also helps in looking at language in real world scenario. So the corpus is a natural language usage in real world, and therefore the sentences here are not really very well-formed sentences in the sense that one would normally look at in a grammar or in a linguistic textbook. Here, these are sentences used by people as they use them in everyday communication. Building large-scale annotated corpus therefore becomes a necessity for doing good computational modeling for processing natural languages. The question that comes next is, what information needs to be annotated? And a related question is, for annotating, what kind of standards are required? So for each level of analysis, one needs to manually annotate the data, and for that, one needs standards so that data across annotators and across people is annotated the same way, which is a very, very important property for modeling computational models. For preparing the data for annotation and also for processing, the first step in a corpus is splitting sentences. So splitting the text into sentences. For example, if we take a conversational text, Mohan should drive, never mind, I'll drive. Now one should be able to split the sentence into two. Here, one is Mohan should drive, never mind that, I will drive. Example 2 from a tweet, traveling to Delhi tomorrow, kabaddi gonna be fun. Now this is a very unstructured sentence in the formal sense, and to identify where one sentence ends and the other begins is very difficult, a really challenging task. In this case, traveling to Delhi tomorrow, part of the next sentence is missing. This is the normal language, how it is used in tweets. Kabaddi gonna be fun. These are two different sentences. So the first step is tokenization. So after splitting the sentence, within a sentence one needs to split the sentence into tokens, or for our purpose we will call them as words. Dividing text into tokens, that means we need to identify each word by itself. Establishing computational units for analyzing text. And these are part of speech tagging marks tokens with appropriate part of speech label. In Penn Tree Bank, which is a very famous tree bank, there are 35 part of speech tags for annotating all the tokens. Now, Tree Bank itself is a resource, a linguistic data resource, where every sentence is manually annotated for its structural analysis. And therefore, each sentence is represented as a tree structure. In Penn Tree Bank, which is a tree bank for English, 35 part of speech tags have been used. In a Hindi dependency tree bank, 45 part of speech tags are used. The question is, a problem that is addressed in computational linguistics is how to identify the part of speech class label for each token. For example, in a sentence such as he is sitting in the class, how would machine automatically identify that he is a pronoun, is an auxiliary, sitting is the verb, in is a preposition, the is a determiner, and class is a noun. So one relies on various kind of linguistic analysis to do so. One looks at the morphological form and assigns the label. One also looks at the syntactic category. So sitting is morphologically a verb, and is an auxiliary in our example because it is occurring before sitting, the verb. Its lexical function, and therefore there are different kind of information that one uses. These linguistic aspects may differ from one language to other, and therefore the labels that languages choose may be different. Hence 45 part of speech tags for Hindi and 35 for English. Apart from differing linguistic differences in different languages, there is also an issue of granularity when one chooses part of speech labels for annotation in a given language. One can go for finer level of analysis or remain at the course. For example, one can just annotate a noun for all kinds of nouns, or one can choose to annotate something as a noun and a proper noun. The other issue that comes is whether the tag labels should be hierarchical, that means noun going to proper noun, common noun, or at a flat level, that means you have common noun, proper noun at the same level. The next step in the analysis is morphological analysis. In morphanalysis, one analyzes inherent invariants of same lexical stem. And as is known, morphological analysis can be inflectional or derivational. Identifying various word forms of the same stem is part of morphological analysis. And for doing that, one also looks at contextual variables of gender, number, person, time, aspect, and modality. One also tries to disambiguate homonymy. So there could be noun, third person, singular, neuter gender, or play, verb, perfective, neutral gender. So the play word in English is ambiguous, and one analysis is noun, third person, singular, neuter, and the second analysis is verb, perfective, neuter gender. Therefore, morphology has to be predicted in context. John is playing where play is to be analyzed as a verb. The next step is chunking, which is an exercise of grouping the words together to form a non-nested, closely bound units. One also calls it shallow parsing. The structure in a chunk is non-overlapping, and they are internally structured units. That means the words within a chunk are related to each other. For example, the tree on hilltop is a big fir. One would chunk it as the tree on hilltop is a big fir. Every chunk is a constituent structure. It is a minimal phrase structure wherein there is always a head. So the chunk labels are according to the head of the chunk. And head word decides the category of a chunk. For example, in our example, the tree is the head, and therefore it is an NP. On hilltop, top again is the head, or one can take on as the head, and therefore it's a PP. Is a verb. A big fur is the head, and therefore it's an NP. So the tree is an NP, on hilltop is a PP, is a VP, a big fur is an NP, and one also chunks the punctuations, and therefore one has a chunk sim. The issue in chunking is about what kind of features one selects here, the chunk features or lexical features. For example, when we are looking at NP, do we take the features that one gets from the tree, or should one take the features of the and features of tree? The next level of analysis is called parsing, where sentences are analyzed in terms of the relations that the words hold within a sentence. Shallow parsing is one level of analysis, as I said, up to chunking, which includes part of speech tagging, chunking, named entity recognition, and morph analysis. Here, the relation between chunks are not identified. Full parsing or deep parsing is parsing where fully connected trees with relations between words are formed. And what one needs here is modeling syntax as grammars. So several grammar formalisms are there in the field of linguistics, and one can choose from any one. In parsing formalisms, there are two most popular parsing formalisms are: one, constituency. Constituency is in constituent parsing, hierarchical relations between words and word groups are identified and represented. So in our example, Mohan plays with the ball, one sees a phrase structure tree where the ball, determiner and noun form one NP, and with the ball becomes one PP, plays with the ball becomes a VP, and Mohan plays with the ball gives us a full sentence. The other formalism, which is very much used in computational linguistics, is dependency parsing. In dependency, relations between words are connected by looking at the nodes and seeing head and dependent relations. So in the same example, place becomes the root node because it's a verb, and Mohan and ball, it's two children, where Mohan and ball are the dependents of place. Ball has two dependents, with and the. So in a dependency tree, the lexical nodes form the nodes in the tree. Semantics is about extracting meaning from text, and when one is trying to understand the semantics of an input text, then what is it that one is looking for? More than that, where should one look for it? So at the level of words, one looks at their lexical meaning. At the level of clauses, one looks at how an event is structured. Meaning in the way the words are distributed, one looks for word relations. And for doing all this, one needs ontologies as knowledge base. For example, one needs to have some kind of lexical semantics, semantic knowledge basis to interpret the meaning of words. So the issue while working with semantics is what kind of meaning one is looking for. Words are ambiguous, and looking at lexical meaning, one can find several meanings of a word, and therefore one looks for meaning of a word in context. And this is what leads to natural language understanding. The next level of analysis while analyzing a text is discourse analysis, where one is trying to understand or extract meaning from a collection of sentences. In a discourse, there is an interplay of multiple events. Events are structured in a way in a text that there is cohesion. So information is in cohesion. Understanding conversations is another aspect where there is dialogue and there could be a lot of pieces of information missing. Example, can you pass the salt, please? Now this is a pragmatic usage, and to interpret the meaning here, one needs to have much larger context, maybe even the idiomatic usages of this sort, or the pragmatic usages. The speaker too passes the salt and says, sure. In normal context, or if we interpret this sentence literally, what speaker one uttered, that is just an action sentence which is saying, pass me the salt, can you pass the salt? It is a yes, no question, and therefore one can respond yes and not pass the salt. But because of its pragmatic usage, one is expected to pass the salt, and that is what the speaker too is doing by saying sure. The methods and formalisms used for analyzing text at various levels, one will be looking next. So methods and formalisms, one of the tools that is available to computational linguists are finite state automata, and this is most frequently used for morphanalysis. Now these are machineries where one gives an input which passes through various states and transitions, and you get the final output. In our case, we can take one example, say unclear, say clear. So clear as an adjective goes to the input, Q0 level. From there, there are two paths. On one path, there is un prefix available, which takes to the next state, which is Q1, and one has unclear as one's output. From unclear, it goes to the finite state with the double circles, Q2, and you have an adjective unclear. On this adjective unclear, one can apply various suffixes such as er, ly, est, and each one of them would give the output again at the finite state as unclearer, unclearly, unclearest. If one takes the second path, going from Q0, the first transition is empty, and one reaches Q3, which again bifurcates. So from Q3 one can directly go to Q2, and so clear, there is no unsuffix, so clear, clearer, clearly, clearest. Or take another finite state to clear, and from there goes to clearer and clearest. The kind of grammars that are available for developing computational models are considered to be of two types. One, context-free, and the other context-dependent. Phrase structure grammars, for example, are context-free grammar because on one side you don't have any context, you just have rules. Whereas there are context-dependent grammars where the rules on one side have context and the other provides the change, how it is changing. Examples of different kind of grammar formalisms that are available for computational modeling are tree-adjoining grammar, lexical function grammar, and computational Paninian grammar, which is used by several Indian groups. Formalisms or grammar formalisms is an outlook towards the language. So one looks at the language, takes an input and can analyze it in different ways, looking at it from different perspectives. Once we have the grammar formalism, one can then choose a method in terms of whether one wants to go rule-based or one wants to use statistical methods. Rule-based systems have their advantages. They are more accurate because rules are definite conditions and they provide you output which is expected to be more accurate. At the same time, rule-based systems tend to be less exhaustive as one needs many rules to cover entire grammar. So very often they are not robust. That means there are times when they fail, when they do not provide any output for a given input. Statistical systems are probabilistic, therefore they give output based on the chances of something being X or Y, so they predict the output, and they are robust because they will always predict some output for a given input. However, they may not be as accurate as the rule-based system. There are issues in all these tasks that we've been looking at, and linguistic issues we'll look at first. So the issue before anyone who chooses to go for any level of analysis, any one level of analysis that we've been looking at, are, as we discussed for part of speech tagging, whether the analysis should be done going deeper to a finer level of granularity, or should it remain shallow to a coarser level of granularity. As we have taken the example, one can talk about a noun, giving it a noun tag by saying it's just a noun, or one can talk about a common noun and a proper noun. One can talk about a mass noun and a count noun and go to the third level of analysis. This is always an issue, and depending on one's end goal, often one chooses one's level of depth for analyzing or coming up with a with a grammar. For example, certain tasks such as information extraction, etc., do not need very deep level of analysis, but need efficient analysis, efficient performance, and therefore they don't go to a very deep level of analysis, they work at a shallow level. However, if you want to go for machine translation, and particularly for two languages which are linguistically more distant, then one needs to go to a deeper level of analysis. In fact, sentence parsing is very common, but one also needs to look at the discourse, and in full sentence parsing, one needs to also bring in the semantics, or rather the meaning component explicitly marked, so that the translation quality can be much better. Now, choosing the depths of linguistic analysis also brings in other issues, which is whether one would be able to, in a consistent way, analyze the given input in an accurate way. So what is the feasibility of analysis, whether it is possible at all or not? Because there are areas when one goes deeper which become gray. And along with it, there is also the other aspect, which is cost of annotation. To be able to analyze something more at a deeper level, or to a deeper level, one also needs to have annotated corpus on which a model can be trained, and that annotated corpus, while doing the analysis, human annotators sometimes find decision making more difficult if the level of annotation is finer. So the cost of annotation is also an issue. A very common method for parsing in computational linguistics today is data-driven parsing. In this method, one extracts the information from the unstructured text. That means a text is given on which a machine learning algorithm is trained, which learns from the given input training component to predict analysis for a new sentence. And for being able to predict analysis for a new sentence, it should learn from the given training set what kind of information is available. Another issue that very often comes, as I already said, depending on the depth, depending on the task, one chooses the depth. Similarly, whether one should go for shallow parsing or a more deeper parsing which leads you all the way to deeper meaning is another issue which always confronts computational linguists. Developing technologies which are efficient needs efficient performance, and that means going to deeper level of analysis requires more resources, which makes the system slow. So whether you want technologies which can work efficiently in a real world scenario, or you want a deeper understanding of the text and what is coming to you. So the question now is, how much analysis? Capturing linguistic intricacies is another issue. Slight nuances. The example we took earlier about, can you pass the salt please, requires a whole lot of pragmatic knowledge. Now, how does one capture it? So the conclusion is, language processing for technological purposes is what computational linguistics does, but then it also, so for machine translation, summarization, information extraction, personal assistance, etc. But it also helps towards better understanding of language, because in computational linguistics, one is looking at large body of real language texts. It leads, or it relates to areas such as social linguistics and neurolinguistics, because one needs the knowledge of these fields to be able to more accurately extract meaning from a given text, because they are integral parts. The field also relates to areas such as social linguistics and neurolinguistics, and also psycholinguistics. And those are the areas which are connecting to computational linguistics in the recent times, because to interpret a text or a sentence more accurately or more in a meaningful way, it is also important to put it in its social context. Apart from that, the neurological and psychological aspects of language articulation and understanding is also important to understand. So the field also connects to those two areas.